All right, go ahead and prepare your notes for Cornell Note form. Make sure I give myself more of a column this time. And we are on page 49 and 50 of our textbook. And we are dividing decimals by whole numbers. And what I mean by whole numbers is we're not dividing by a decimal, we're dividing by a whole number. So say for instance, I'll give you the first example. Say we want to divide 5 and 6800ths. Well, I want to divide it by a whole number, which is 4. So this number is not a decimal, it's a whole number. Get a different colored pen. Okay, so the rule with dividing decimals by whole numbers, put the rule here. Always a rule, right? Divide as if no decimal. That's step 1. Divide as if there's no decimal. Pretend that decimal is not there, okay? Step 2, or rule number 2. Let it rise to the quotient. Don't forget, quotient is up here, right? And then you're thinking, let what rise? Let the decimal rise. Okay, once you're done dividing, you're just going to shoot that decimal up to the top. So really, those are the only two rules to dividing decimals by whole numbers. So if I use this as an example, so 5 and 6800ths divided by 4, I'm just going to divide as usual, right? I'm going to ignore that decimal. So 4 goes into 5 one time. 1 times 4 is 4. You need to make sure you're really good with long division here. 5 minus 4 is 1. And then you're going to drop down that 6, right? Because 4 doesn't go into 1. So drop down that 6, and 4 goes into 16. 4 times 4, 16. And then we're going to subtract the 2. 16 minus 16, 0. Okay, well 4 doesn't go into 0, so we got to drop down that 8. How many times does 4 go into 8? 2 times. 2 times 4, 8. 8 minus 8 is 0. And there's no more digits I need to drop down. So our remainder is nothing, right? And then, so I divided as if there was no decimal. And number 2, I let it rise to the quotient, which means I need to bring up that decimal and put it right in the quotient. Perfect. Okay. So we are going to start on example 1 on page 49. So I'm going to move down a little bit. This is page 49, and this is the first example. That says example, so I know where I'm at. Okay, number 1. Find 6 and 8/10 divided by 2. Okay. 6.8 divided by 2. So I'm going to divide as if no decimal. Okay, so 2 goes into 6 3 times. 3 times 2 is 6. 6 minus 6 is 0. So that's when I drop down my 8. 2 goes into 8. How many times? 4 times, right? 4 times 2 is 8. Subtract 8 from 8, and that is 0. And then my last step is to let it rise and put the decimal right in between the 3 and the 4. So your answer is 3 4/10. Okay, let's try this on letter A. Letter A is 7 5/10 divided by 3. 7.5 divided by 3. Perfect. Okay, so how many times does 3 go into 7? 2 times, right? 2 times 3 is 6. 7 minus 6 is 1. 3 doesn't go into 1, so I drop down that 5. 3 goes into 15 5 times, right? And then I let it rise. The decimal just goes straight up. 5 times 3 is 15 and 0. Let's go to B. We have 7, let's see, 3 5/10. My pen's going out. 3 5/10 divided by 7. So 7 doesn't go into 3, right? So we have to go, how many times does 7 go into 35? It goes in 5 times, right? So the 5 gets put right up below the 5 in the 1's place. 5 times 7 is 35. And then 35 minus 35 is 0. And then I raise up that decimal. So the decimal goes right in front of the 5. Okay, we're going to skip C and turn the page to page 50. I'm going to turn this page. Ran out of room. And I'm going to put it in Cornell note form. And we are on page 50. All right, so we are up at the top of page 50 where it says 2. Gonna learn a strategy. I don't know why I put a circle over the 2. Should have done a half parentheses. Okay, so we're going to find 7 7/10 divided by 14. So first of all, we've got to look at how many times does 14 go into 7? It doesn't, right? Does 14 go into 77? How could we figure that out? When we do a double-digit divisor, it's obviously going to be a little bit harder, right? It takes a lot more work because we are forced to take this double-digit divisor into whatever large number dividend we have. So when we have a double-digit divisor, your first step, I'll write it off to the side, our double-digit divisor, our first step is to estimate, okay? And in order to do that, we have to think, well, how many 14s go into 77? How many 14s go into 77? If we look at our book, it already tells us about 5 of them. So if we were to round, we could say, oh, gosh, how many 15s go into 75, or how many 14s go into 70, but pretty much you would have to just do some multiplication on the side to guesstimate. So far 5. Okay, and then here's a trick. 5 times the first digit, 5 times 4 is 20. We drop the 0, carry the 2 up here. 5 times 1 is 5, plus 2 is 7. So if you want to actually just kind of do the math on the side, like, oh, what is 14 times 5? You could do that too and then plug it in here. But I like that little trick. So 77 minus 70, we're left with 7. And 14 doesn't go into 7. and we have no more digits, so what do? We can't have a remainder. So what we do is we annex, right? Annex a 0 if needed. So I'm going to put that 0 here and drop him down. Okay, so how many times does 14 go into 70? Well, we just figured that out. It was 5. So 5 times 14 is 70. 70 minus 70 is 0. Now, we remember our rules, okay? Lift that right up, that decimal right up. So the answer is 55 hundredths. Okay, go down to number, let's see, we're just going to do B. No, that's E. D, E, and F right below number 2. So D is first. It is 15 dividing into 9 and 48 hundredths. Okay, so we're looking at 15 going, okay, how many times does 15 go into 94? Well, 15 goes into 94 about 6 times, right? So let's follow the process. 6 times 5 is 30, right? Drop that 0. Carry the 3. 6 times 1 is 6 plus 3, 6, 7, 8, 9. That is 9 there. So 94 minus 90 leaves us with 4. Now 15 doesn't go into 4, so we have to drop that 48. Okay. So how many times does 15 go into 48? Well, you have to estimate. Okay. Let's see. If it was 2, it'd be 30. So let's try 3. So 3 times 5 is 15. Carry the 1. 3 times 1 is 3 plus 1 is 4. We did it. We estimated correctly. 48 minus 45 is 3. And I am all done with my digits here. But I can't have a remainder when I'm working with decimals. So I've got to annex a 0. Okay, add a 0 there. So I drop that 0 down to make this a 30. Well, that's easy. How many times does 15 go into 30? 2 times. We got lucky on that one. 2 times 15 is 30. There we go. Now we have a 0 remainder. So you just would annex a 0 until you have a 0 remainder when you're working with decimals. Now don't forget to raise up that decimal. So our answer is 632 thousandths. Okay, E, we'll move over to the side for E. E is 3 and 49 hundredths divided by 4. All right, so 4 does not go into 3, so we have to figure out, does 4 go into 34? Well, we know that 4 goes into 32, right? I think 4 goes in 8 to 34 8 times, so 8 times 4 is 32. 34 minus 32 is 2. And now I drop that 9. And now I'm noticing 4 does not go into 29, but it does go into 28 7 times. 7 times 4 is 28. And I have a 1 as a remainder, but remember I'm working with decimals, so I can't have a remainder. I need to annex a 0. So drop that 0 down. Now I have a 10. Does 4 go into 10? Think about that. So 4 doesn't go evenly into 10, so it looks like I have to keep going. 4 goes into 12, 4 goes into 8. So I'm going to try the 8. 2 times 4 is 8, and I have a remainder of 2. Again, when I'm working with decimals, can't have that remainder, so I have to annex another 0 and drop him down. So now I need to see how many times does 4 go into 20. Does 4 go into 20? does. Evenly. Heavenly Jesus, thank you. We are done with this problem. 5 times 4 is 20. And we have finally no remainder. So how many zeros did we have to annex? 2, right? And then our last rule is to raise up that decimal. So the decimal goes right up here, and our final answer is here. All right, we're going to do one last problem and be done. So we're in F, and we have, let's see, 55 and 800ths divided by 17, another double-digit divisor. Okay, so just like my rules, you have to estimate first. So 17 goes into 55. Gosh. Well, let's think if this was 15 going into 60. If it was 15, if it went in twice, it would be 30. So I'm going to try 3 times. I'm going to estimate 3 times. And then I go 3 times 7 is 21. Almost lost that for a second. Drop the 1, carry the 2. 3 times 1 is 3, plus 2 is 5. Nice. I did a pretty good estimate, because if it was 2, I would be too short. So 55 minus 51 is 4. 17 does not go into 4, so I have to drop this 0. Then I have to think, how many times does 17 go into 40? Well, I realize that 17 goes into 55 3 times, so maybe I'll try 2 this time. I think 17 goes into 40 2 times. Let's see if I'm correct. 2 times 7 is 14. Carry the 4, or drop the 4, carry the 1. 2 times 1 is 2, plus 1 is 3. Oof, I was really close. I did it. Okay, so now I'm going to subtract 34 from 40, which is 6. And now 17 can't go in to 6, so I have to drop this 8. So now I'm looking at how many times does 17 go into 68. Well, don't forget, we saw 17 went into 55 3 times. So how many times would 17 maybe go into 68? Like, we're just estimating. We don't know the exact answer, right? We're just estimating. Well, if it goes in 3 times to 55, it must go into 68 maybe one more time, right? So let's try 4. 4 times 7 is 28. Drop the 8, carry the 2. 4 times 1 is 4, plus 2 is 6. Holy cow, we got that exact. So 68 minus 68 is 0. So I'm done, and I just have to raise up that decimal. So the decimal's this way, right? So it's going to be raised up between the 3 and the 2. So our final answer is 3 and 24 hundredths. All right, good job, guys. Make sure you do Edpuzzle.